Hello, this is Mr. Win, and this video is about classifying triangles. So triangles can be classified by sides and angles. For sides, we have three different names. We have scalene. Scalene means a triangle with three sides of different lengths. No sides can be equal to each other. Isosceles means a triangle with two congruent sides, so two sides must be equal to each other. And then equilateral means a triangle with three congruent sides, so all three sides must be equal to each other. So you can see these dash marks right here. So this is three equal sides. This is two equal sides. All right, and this is no equal sides because there's different number of tick marks for each. All right. For angles, we have acute, a triangle with three acute angles. Remember, acute means angles less than 90 degrees. Right means a triangle with one right angle, and a right angle is an angle with 90 degrees. And obtuse is a triangle with one obtuse angle, meaning angle with more than 90 degrees. Last, we have equiangular. Equiangular means a triangle with three equal angles, which have to be 60 degrees. So triangle adds to 180 degrees, in case you didn't know that. You cannot have more than one right angle because you need three angles. If one's 90, then the other two have to add up to 90. It can't be 90, 90, and something else. Then obtuse, there can't be more than one obtuse angle because two obtuse angles already make more than 180. Alright, so triangles are named using three letters, just like angles, but they use the triangle symbol. So classify each triangle as acute, equiangular, obtuse, or right, and explain our reasoning. So first is triangle ABD. So I go on here. Here's A to B to D, and it's a triangle at angles, so we close it. What kind of triangle is that? Look at the angles. There's 360-degree angles. So this is equiangular. All right, also, all three numbers are less than 90, so it's also acute. So it's both. All right. Next one is BDC. So if I'm at B, going to D, going to C, closing this. Look, the angle is 30, 30, 120. I see an angle bigger than 90, so that is obtuse. Then lastly, let's see what we have. ABC, A to B to C. Close it. We have, in case y'all can't do this, 30, 60, and then we add this together. This is 30, 60, 30 is 9. This is a 90-degree angle. So if we have a 90-degree angle, that is right. By the way, remember, just looking at angles by themselves do not tell us what the side lengths are. So I have no clue how long each side is. I mean, if you go back to this 60, 60, 60, this equal angular or acute triangle, I don't know if each side is 10 inches long, 10 feet long, 100, 3. We don't know the sides at all. Sides can be whatever they want using a ruler or measuring device. All right. Now, although angles can't tell you how long the sides are, there is a relationship or a connection between them. An angle pairs with the side directly across from it, and the reverse is also true. So a side pairs with the angle directly across from it. So consider this drawn scale triangle. All right, we have a 90-degree, it's a right triangle right here. It's 90 degrees, so just put the 90 there. 37 degrees for Y, 53 degrees for R. Now notice that angle T, if you use one, or angle RTY, if you use three letters, although T is only one angle here, is a right angle. You've probably heard in a right triangle, the hypotenuse, in this picture is side RY, is the longest side. That's because it's related or paired with the largest angle, 90. So if I'm 90 degrees, I go straight across, they go together. So angle T is related to side RY, and vice versa, and go backwards, right? RY is related to angle T. Notice the next one, angle R, or angle TRY, if you use three letters, is the second largest angle. So the side related to that, which is side TY, will be the second largest side. So 53 degrees goes with this, and vice versa. So the angle R is related to side TY, and vice versa. I can draw this arrow either direction. Let me do that. Let me add the arrow here. All right, and lastly, angle Y, or TYR, is the smallest angle, so it's related to the smallest side, which is RT. All right, and again, vice versa. So angle Y is related to RT or TR, your choice. The same side. All right, make sure you know those connections. It's very important. So that relationship can help us set up equations. Specifically, if two angles are the same, then the sides across them are also the same. And the reverse is true. If two sides are the same, the two angles across them are the same. So with this in mind, let's update the definitions of some triangle classifications. So an isosceles triangle has two equal sides and 2 equal angles. An equilateral triangle has 3 equal sides and 3 equal angles. All right, an equilateral triangle is by default equiangular, so all angles will be 60 degrees. The reverse is true. If an triangle is equiangular, it is by default also equilateral. 3 equal angles means 3 equal sides. Some more specific vocabulary. For isosceles triangles, again, 2 congruent sides, or at least 2 congruent and 2 congruent angles. The congruent sides are called the legs. The congruent angles are called the base angles, and the base is the side located between the 2 legs. So notice I drew the arrows in green. Those base angles are the same, and I drew the diagonal green line to show which legs are the same. So this leg is connected to this angle, and this leg is connected to these angles. Since the legs are the same, the angles are the same. They might turn this isosceles triangle sideways or upside down. All right, base angles go to the legs. Equal base angles, equal legs. All right, let's try some solving, or just a little more naming. When naming a triangle, we can use a combination of side and angle classifications. So draw an isosceles right triangle. There you go. That's a right triangle with 90 degrees. Look, isosceles has 2 equal sides. I also know that these 2 angles have to be the same because they have 2 equal sides, we have 2 equal angles. I have the angle mark there. If you get more technical, because a triangle makes 180, if that's 90, then these are going to be 45, 45. Because all 3 numbers add to 180. All right, draw a scalene right triangle. Well, there you go. 90 degrees. Then we have all 3 different sides. So 3 different sides implies 3 different angles. Now we have no clue what the sides are, but we know that all 3 angles will be different. Now it is impossible to have an equilateral right triangle. Why? Equilateral means equal sides, and equal sides implies equal angles. You can't have a triangle with 3 right angles. That would be 270 degrees. That's too much. All right, same thing, but isosceles acute. That's possible. Notice these 2 sides are the same. If I go across from them, those 2 angles are the same. And then the third angle is 80. So 50, 50, 80, all 3 angles are less than 90. So that is an acute triangle. And 2 sides are the same, so that is also isosceles. I also have a scalene acute triangle. All 3 angles are under 90, and all 3 sides are different. That's because all 3 angles are different. 50, 60, 70 does make 180. Same for 50, 50, and 80. All right, is it possible to have an equilateral acute triangle? Answer is yes. I had one earlier. Remember, equilateral means all 3 sides are the same, which implies all 3 angles are the same, which has to be 60 degrees. Are 60, 66, is that under 90? Yes. Earlier I named the equilateral and acute triangle for the first problem. All right, and then the last one, obtuse ones. Can we have isosceles obtuse? Yes, we can. Obtuse means one angle is more than 90, so we have 110. And these 2 sides are the same, which means these 2 angles are the same as the cross ones. And technically, since a triangle makes 180, you know, if I do 180 minus 110 is 70, each of these is going to be half of 70. So this is 35 degrees, 35 degrees. That is an obtuse triangle. That's also isosceles. Can we draw a scalene obtuse? Yes, we can. Also, by the way, I made this one figure, not drawn to scale. Remember, you cannot assume how a picture looks. I intentionally made this look like it's 90 degrees, but it's not 90. It says it's 20. You use the markings or numbers that's already there. All right, so in this case, because this is 100 degrees right here, I'm telling you this side is the largest side, although it doesn't look like it. And this is the middle angle. That means this is the second longest side, even though it doesn't look like it. And then this last one, the smallest angle, this means this is the smallest side, even though it doesn't look like it. And trust the numbers, not the picture. Anyways, is that an obtuse triangle? Yes, because it's one angle over 90. And all 3 numbers do add up to 180. Is it scalene? Yes, because all 3 sides are different. And I know 3 sides are different because the 3 angles are different. Equal sides mean there's equal angles, and vice versa. Now, it is impossible to have an equilateral obtuse triangle. Again, equilateral means all sides are the same, all angles are the same. If we need obtuse, can we have 3 obtuse angles? No, that's more than 180. All right, let's do some solving. Solve for y, then find each angle. Notice this triangle is isosceles. I know because of this mark right here. All right, remember, those 2 equal side marks mean there's 2 equal angle marks across from them. So this angle is equal to this angle. That's going to be our formula. It's going to be angle equals angle. So the first angle, I'll call it a 4y minus 10 equals the second angle, 2y plus 30. I'm going to subtract 2y both sides to make 2y minus 10 equals 30. I'm going to add 10 both sides, so that's 2y equals 40. I'm divided by 2, y equals 20. I found y. It said Find each angle, plug it in. So this is 4 times 20 minus 10. That's 80 minus 10. That's 70. We found the top angle. Let's check the bottom angle. 2 times 20 plus 30. That's 40 plus 30. That's 70. Well, I knew that. They're the same angle, right? So I knew one, I knew the other. And over here, 3 times 20 minus 20. 60 minus 20. That's 40. Notice 40 plus 70 plus 70, that is 180. So the triangle makes 180. Here's another one. Solve for x. Now this triangle is not drawn to scale. Again, don't let the picture trick you. Use the marks. They have 2 equal angle marks. So if you have 2 equal angles, you also have 2 equal sides. This is another isosceles triangle. This angle goes to this side. This angle goes to this side. So I can add the marks here. These sides, 2 sides are the same. All right, so my formula here is going to be side equals side. All right, so for isosceles triangles, equilateral triangles, the only formulas you're allowed to use is angle equals angle or side equals side. So the first side, 2x plus 8, equals the second side, 20. You would not use that 30 at all. Subtract 8 both sides to make this 2x equals 12. Divide by 2, you get x equals 6. It does not say plug in, so we're good. But 2 times 6 is 12, plus 8 is 20. So we have 20 and 20. All right, if the triangle below is equilateral, find x and y. All right, so now we need to think, what's equilateral mean? Equilateral means 3 equal sides. So lateral means side divided another, so equal means equal. So those 3 sides are the same. So I'm going to do the formula side equals side. Now, which side am I using? It does not matter. Pick the 2 you like, your favorite 2. Let's do this one and this one. All right, so x plus 5 equals 3x minus 5. Solve for x. I'm going to subtract x both sides, so 5 equals 2x minus 5. Add 5 to both sides, so that makes, let's see, 10 equals 2x. Divide by 2, you get 5 equals x. We found x, we plugged in, we didn't say plug in, but 2 times 5 is 10. 5 plus 5 is 10. 3 times 5 is 15, minus 5 is 10. Like all 3 sides are 10, that's good. They're supposed to be the same. Now it has y and an angle. So do we know any angles about equilateral triangles? Yeah, we do. We know all 3 angles are the same, but also all 3 angles must be 60. So that's my next equation. Because I'm not going to say 4y plus 20 equals 4y plus 20. I'll say all of these are 60. Right, if 2 things take up the same spot, they're the same thing. So we're going to say 4y plus 20 must be 60 because 60 goes in that spot. We're going to subtract 20. We're going to divide by 4. And that's it. All right, make sure you ask any questions in class. Thanks for watching. See you soon. Bye.